Hey guys, welcome back. This is the next installment of simple harmonic motion with springs. These are all multiple choice questions that were on the AP test that deal with springs in this section. An ideal spring obeys Hooke's law, F equals negative kx, mass of 0.5 kilograms, hung vertically from the spring, stretches the spring 0.075 meters. The value of the force constant for the spring is most near. So F of S is going to be equal to negative kx. The force is going to be 5 newtons for a 0.5 kilograms, and we're saying that it stretches at 0.075. So I have 66.7. Two pucks are attached by a stretched spring initially held at rest on a frictionless surface. As shown above, the pucks are then released simultaneously. If puck 1 has 3 times the mass of puck 2, which of the following quantities is the same for both pucks as the spring pulls the two pucks towards each other? The amount of momentum that they have would be the same in magnitude, right? Because they start with no momentum. And so that would mean that the momentum of one and the momentum of the other one added together would have to equal 0. When a mass is attached to a spring, the period of oscillation is 2 seconds. When the mass attached to a spring is doubled, the period of oscillation is most nearly. So put in ones for everything and then change the mass to 2. It's going to give me radical 2. Radical 2 times 2 is going to give me 2.8. A block oscillates without friction at the end of a spring as shown above. The minimum and maximum lengths of the spring as it oscillates are respectively x min and x max. The graphs below can represent quantities associated with the oscillation as function of length x of the spring. Which graph would be the total mechanical energy? If there is no friction, so no non-conservative forces, the total energy would be constant. It would be E. Which graph represents the kinetic energy of the block as a function of x? It's going to be going the fastest in the middle. So it needs to be either C or D. And then the question is kinetic energy, how is it related to distance? Well, kinetic energy is 1/2 mv squared, but it's going to be the opposite of the spring energy, which is 1/2 kx squared. I just wrote that. So because of this x squared is directly proportional to spring energy, and spring energy is related to kinetic energy. It's going to be the opposite, right? Our spring energy would be the sad face underneath. When an object oscillates, can you read that? I hope you can read it. When an object oscillates in simple harmonic motion at a maximum displacement from equilibrium position, which of the following is true of the value of its speed and magnitude of restoring force? At maximum displacement, the restoring force is a maximum and it's not moving. It has all spring energy. A particle oscillates up and down in simple harmonic motion. Its height y as a function of time is shown in the diagram above. At what time does the particle achieve its maximum positive acceleration? Again, we know that kx is ma. So when this is negative, that's going to be positive, and when this is the biggest, so it looks like negative a happens at 1 second. So the force is proportional to the acceleration. The acceleration is proportional to displacement, and the displacement and acceleration are in opposite directions. The graph above represents the potential energy as a function of displacement of an object on the end of a spring oscillating in simple harmonic motion with amplitude x naught. Which of the following graphs represents the kinetic energy? So the kinetic energy added with the potential energy is going to add up to a straight line. So D represents that, right? So if we had the D one like that, those two together would be a straight line.